Hey everybody, and welcome to McArdle Math Academy. In this video we will be doing an example in which we use the method of partial fractions to evaluate an integral. The example that we're going to be doing involves the function 8 over x to the fourth minus 1. So let's first decompose this into its partial fraction decomposition. And we know that the first step is to factor the denominator as much as we can. So we notice that the denominator is a difference of squares, which factors to the following. And we can go one more step because the first piece here is another difference of squares, so this will factor to the following. So that's the fully factored version of this rational function. And from there, we determine what the form of the partial fraction decomposition is, and I'm going to write that in red. Your first factor is x minus 1, so that has a form in the partial fraction decomposition of a over x minus 1. The second factor, x plus 1, same thing, it's a non-repeated linear factor. Your third factor, x squared plus 1, is an irreducible non-repeated quadratic factor. So you have the form cx plus d over x squared plus 1. So that's the form of our partial fraction decomposition, and we set that equal to the actual rational function that we started with in its factored form. Okay. So now the next step is to take this equation as a whole and multiply both sides of the equation. So I'm going to zoom out a little bit. Multiply both sides of the equation by this denominator. Alright, so on the right we're going to multiply by that, and on the left we're going to multiply by that. Alright, so that leads us here, and we notice that on the right this entire term will cancel. And on the left, if you distribute this into each piece, you're going to notice that each piece is going to cancel a little bit, and I'm going to write down what we get after that expansion. Alright, and now once we're at this point, our job is to find a, b, c, and d. So what we're first going to do is we're going to set x to be strategic values. So we know that this equation holds for all values of x, so therefore it has to hold for x is negative 1. And we see that when we do this, this first term is going to become 0. This last term is going to become 0 because of this factor here. So all that's going to be left is this term here where we plug in minus 1. So you're going to have b times negative 2. So that shows us what our b value is. And the same thing can be done for x equal 1. You're going to notice that this term is going to go away and this term is going to go away, leaving you only with this. Plugging in 1, we're going to find the following. Alright, and now our new equation we can form by plugging in 2 for a and minus 2 for b, so then we can kind of deal with c and d separately. So with our new equation here, I'm targeting c and d, so I'm going to choose x to be 0 so that I can target d in particular. And plugging x to be 0 into this entire equation, we see that the c term is going to cancel out, and we're going to be left with the following. So that leads us to d being negative 4, and to complete the job, we're going to put that minus 4 in for d here, and then we're going to choose x to be anything else because the equation now is only involving c. So I'm going to choose x to be 2. You plug 2 into this equation for x, and we'll solve for c. And when you do that, you're going to find that c is 0. So that's a good little exercise to do on your own to check that that this makes sense. Alright, so what do we have? So this is our partial fraction decomposition. Here's your a, here's your b, and here was your d, and the c became 0, so that obviously does not appear in the final decomposition here. And this is what we're going to use when we get to the next problem with integration. So if we're presented with this integral now with the same rational function, you look at this and you will break it up into its partial fraction decomposition, which we just found. And then we can integrate each of these pieces separately. So I'm going to spread the integral over all three pieces. And the first two pieces require very small integration by substitution, where you use w to be that denominator. And I'm not going to go through that procedure, but you're going to find that the answers will be 2 ln of x minus 1 minus 2 ln of x plus 1. Now the last piece here, the last integral that we have to deal with, is going to require a trigonometric substitution, and it's actually going to be a tangent substitution. Now I made another video on this topic, so I'm not going to go into detail here, but you'll find that the answer is minus 4 arctan of x plus c. So this would be the final answer to our integral. Don't forget the plus c. If we took a derivative of that and simplified it, you can find that it'll get you back to where you started. All right, see the video on the trigonometric substitutions for this integral, and hopefully this helps. See you next time.